Have you ever wondered if we could use wormholes as shortcuts through space? Imagine a universe where the vast distances between galaxies shrink to a manageable commute. Picture a reality where we can voyage to the furthest reaches of the cosmos in the blink of an eye. This is the tantalizing promise of wormholes, a concept that has captivated scientists and science fiction enthusiasts alike. Wormholes, as theoretical as they may be, are fascinating constructs of the cosmos. In the realm of theoretical physics, they're considered as shortcuts through the fabric of spacetime, a tunnel connecting two distant points in the universe. This means that if we were able to harness the power of a wormhole, we could potentially travel from one end of the universe to the other in a fraction of the time it would take light to make the same journey. But how do wormholes fit into our understanding of the universe? Well, they are a prediction of Einstein's general theory of relativity, which describes gravity as the warping of spacetime by energy and matter. Essentially, a wormhole is a shortcut through this warped spacetime. Of course, this all sounds like the stuff of science fiction, and indeed, wormholes have been a popular plot device in many sci-fi books, movies, and TV series. They've been used to explain everything from time travel to interstellar travel, often with a healthy dose of artistic license. But science fiction aside, could wormholes actually exist in our universe? And if they do exist, could we ever harness their power for space travel? The truth is, we don't know for sure. The existence of wormholes is still purely theoretical, and the technical challenges of creating or finding a wormhole, let alone traveling through one, are immense. However, that doesn't mean we can't speculate. In fact, some scientists have proposed intriguing methods for creating wormholes. While these methods are still highly theoretical and far beyond our current technological capabilities, they do provide some fascinating food for thought. So, without further ado, let's dive into the top 5 ways we could potentially create a wormhole. The least likely method to create a wormhole involves cosmic strings. Now, what are these cosmic strings? Picture thin strands of energy left over from the Big Bang, stretching across the universe. They're so dense, even a mile-long string would weigh as much as our entire planet. Now here's the theory. If two cosmic strings were to pass by each other at just the right speed, they could twist space-time into a loop, creating a wormhole. Sounds simple, right? But there's a catch. These cosmic strings, if they exist, are incredibly elusive. Even our most advanced technology has yet to detect them. So, how likely is this method to work in reality? The truth is, we don't know. The concept of cosmic strings is based on mathematical equations, not empirical evidence. So, while fascinating, the existence of cosmic strings remains unproven. Before we continue, make sure to subscribe, follow, like, comment, and share our video. If you're enjoying this journey through the cosmos and the intriguing possibilities of wormhole creation, we'd love to have you as part of our community. Your engagement fuels our exploration into the scientific unknown. So, if you want to continue uncovering the mysteries of our universe together, don't forget to hit the bell icon for notifications on our latest content. Now, let's move on to our next method. Next on our list is the creation of wormholes through quantum foam. Now, what on Earth, or rather in space, is quantum foam, you ask? Well, let's dive into it. In the world of quantum mechanics, there's a theory that space isn't smooth, but rather it's foamy. This foam is made up of tiny, ever-changing bubbles of space and time, each one popping in and out of existence in less than a Planck time, which is the smallest measurable unit of time. It's like a cosmic froth at the very smallest levels of the universe. Now here's where it gets even more interesting. Theoretically, these bubbles could expand into tiny wormholes, creating a network of shortcuts through space and time. Imagine navigating through a sea of bubbles, each one potentially a gateway to a different part of the universe. It's mind-bending stuff, right? However, there's a catch, isn't there always? For these wormholes to be usable, they'd need to be stabilized. And that, my friends, is where we hit a snag. Stabilizing these micro wormholes would require an enormous amount of energy, and currently we don't have the means to harness or control such power. So, while the idea of quantum foam wormholes is fascinating and somewhat more plausible than cosmic strings, it remains highly theoretical. It's a tantalizing prospect that could revolutionize space travel, but for now, it remains firmly in the realm of science fiction. While quantum foam is more plausible than cosmic strings, it's still highly theoretical. The third method on our list involves the use of negative energy. Now, negative energy is a truly fascinating concept. It's not about being pessimistic, mind you, but rather about a form of energy that, in the realm of theoretical physics, could have less than zero energy. Delving into the realm of quantum mechanics, the Heisenberg uncertainty principle allows for the existence of these negative energy particles, albeit for a very short time span. So, how does this relate to wormholes, you ask? Well, wormholes, in theory, need something to keep them open, and negative energy could provide the counterbalance to gravity's natural tendency to collapse and close the wormhole. Imagine this. You're trying to keep a heavy door open, but it keeps wanting to swing shut. Negative energy would essentially be the doorstop, holding that door, or in our case, the wormhole, open. However, before you start dreaming of journeys through space-time, it's important to remember that the existence of negative energy is still theoretical. We've yet to observe or create it in any significant quantities. Additionally, even if we could, harnessing it safely and effectively is another hurdle altogether. Negative energy is a fascinating concept, but we're still far from harnessing it. So, while it offers a tantalizing glimpse into the possibilities of wormhole travel, it remains, for now, a theory within the vast and mysterious universe of quantum mechanics. Our second most likely method involves the use of exotic matter. Now, you might be wondering, what on earth is exotic matter? Well, it's not exactly from Earth. Exotic matter is a type of matter that, in theory, exists in the cosmos, and it behaves quite differently from the matter we're familiar with. Exotic matter has negative energy density and a large negative pressure. In simpler terms, while normal matter attracts other matter due to gravity, exotic matter repels it. Fascinating, isn't it? But how does this help in creating wormholes? Here's the thing. Wormholes, if they exist, are incredibly unstable. They would collapse instantaneously, leaving no time for anything to pass through. But with exotic matter, we might be able to keep them open. Due to its unique properties, exotic matter could create a sort of anti-gravitational effect, counteracting the collapsing force and providing the stability a wormhole needs. Now, as for the likelihood of this method working in reality, it's a bit of a mixed bag. On the positive side, exotic matter isn't just a wild guess. It's a concept that arises from the equations of general relativity, which have been proven accurate time and time again. However, we've yet to detect or create exotic matter. So while it's theoretically possible, it's currently beyond our reach. Exotic matter is more plausible than previous methods, but it remains elusive. We're stepping into the realm of the unknown here, but isn't that what makes science so exciting? The most likely method to create a wormhole involves manipulating space-time itself. Let's delve a little deeper into what that means. In essence, space-time manipulation involves altering the very fabric of the universe. Imagine for a moment that the universe is a sheet of flexible rubber. Now, if you were to push or pull at specific points on this sheet, you'd create a distortion or a dimple. This is, in a simplified sense, what manipulating space-time might look like. But how does this help in creating wormholes? Well, a wormhole is essentially a shortcut through space-time. By manipulating space-time, we could theoretically create these shortcuts, making distances that are light years apart become traversable in mere moments. However, the concept of space-time manipulation isn't as straightforward as it sounds. It would require an enormous amount of energy, perhaps more than what's currently available in the entire universe. Not to mention, we'd need an advanced understanding of quantum mechanics and general relativity, two fields of physics that, despite being proven independently, seem to contradict each other when combined. Yet, the idea isn't completely out of reach. Scientists have been working tirelessly on a unified theory, also known as the theory of everything, which could reconcile these contradictions and pave the way for advancements like space-time manipulation. So what's the likelihood of this method working in reality? Given our current understanding and technological capabilities, it's unlikely in the near future. However, as we continue to explore the cosmos and unravel the mysteries of the universe, the possibility cannot be entirely ruled out. Remember, there was a time when the idea of humans flying was considered absurd, let alone venturing into space. Today, we have not only achieved flight, but have also sent spacecraft beyond our solar system. While we're not quite ready to create wormholes, the future of space travel remains exciting and full of possibilities. So, let's keep our minds open, our curiosity piqued, and our passion for discovery alive as we journey through this fascinating universe together.